So can we say the particles of solute and solvent to be separate? Or if we observe them to be separate, then we call, or if they are not if they do not exactly dissolve with each other, so we call those substances to be immiscible, or they are heterogeneous. So another type of mixture we'll see here, homogeneous and heterogeneous mixtures. So what are homogeneous mixtures and what are heterogeneous mixtures?
Sir, homogeneous mixtures are the mixtures in which the particles are completely dissolved, sir.
Certain homogeneous mixtures are the mixtures in which the particles are uniformly distributed, and heterogeneous are the mixtures where particles are non-uniformly distributed.
See, uniform and non-uniform. First of all, if you observe a homogeneous mixture, so the size of solute particles and the size of solvent particles, they are almost same, and they get mixed up with each other. In homogeneous, you cannot differentiate between the particles of solute and the particles of solvent in a solution. So for homogeneous mixtures, the size of solute and solvent particles, the size of solute and solvent particles is similar to each other. Okay. So, for example, if we consider a mixture of salt and water, okay. So if you have a mixture of salt and water, then what will happen? The salt particles, they are completely dissolved in water, and we cannot identify the particles of salt once they are dissolved in water. The reason being that the size of the salt particles and the size of the particles of water, they are almost similar to each other, and they cannot be identified from the mixture of the solution. So such a solution of salt and water, you have a mixture of sugar and water. So these are called homogeneous mixtures. Got it? Okay, can you give any other example of homogeneous mixtures? Any other example of homogeneous mixtures?
Sir, ink plus water.
Yeah.
Ink plus water.
Okay, we'll come to milk. We'll come to milk because milk itself is a solution.
So not milk,
You have
sir. Ink.
lemon juice and water.
Sir, soda and
That is
water?
also soda and water. Soda and water. So all these are homogeneous mixtures where the size of the particles of solute and solvent, they are similar to each other, and you cannot differentiate between them clearly. So we say that yes, it is a homogeneous mixtures. Then we have heterogeneous mixtures. Heterogeneous mixtures are those where the size of the solute particles is greater than the size of the solvent particles. We have heterogeneous mixtures. So what are heterogeneous mixtures? The substances or the mixtures
In which the size of the solid particles are greater than each other.
Yeah, the mixtures when solute particles are bigger in size bigger in size than the solvent particles. And can be easily identified. Okay. So such a solution is called as a heterogeneous solution or a heterogeneous mixtures. Can you give any examples of heterogeneous mixtures?
Sir, pebbles and water.
What?
Sir, pebble and water.
Okay, very good. Pebbles and water. So pebbles and water, so that is a heterogeneous mixture. Any other? You have pebbles and water, sand and water. Okay,
Sir,
sand and water.
starch powder and water.
Okay, starch powder and water. Very good. Starch powder and water.
Sir,
Anything
milk
else?
and water are not heterogeneous mixtures, right?
Which one? Yeah, Rohit. What other one you were saying?
Sir, milk and water are not heterogeneous mixtures, right?
Which one? Water and
Sir, milk and water.
milk and water. We'll discuss first milk. Okay, milk is a type of colloidal solution. So we'll see colloidal solution later.
Yes.
Okay, so then we'll see what are colloidal solutions. So as we can see, in heterogeneous mixtures, the particles of solute and solution, they do not get mixed up well with each other. Okay, so they can be easily identified. You can have chalk powder and water. Okay. So it is chalk powder and water. It is also a heterogeneous mixtures. Okay, we can see if you have a mixture of chalk powder and water, so the particles of chalk powder, they are easily identified. Let me show you here certain homogeneous mixtures, so heterogeneous mixtures. I'll show you some heterogeneous mixtures of this one, chalk powder and water. So see a mixture of, if you observe mixture of chalk powder and water, the particles of chalk powder, see initially here, we observe when we have kept a mixture of chalk powder and water here in this, the chalk powder, it makes the solution milky. Okay, it seems that the solution is milky. You can easily identify the particles of chalk powder here in the solution. But if you keep it standing for some time, for about 10 minutes or 15 minutes or half an hour, so all the chalk powder which is there, it will settle down at the bottom. So in this solution, we are actually observing the particles of the chalk powder. And the particles of the chalk powder, they are quite big in size. So here we have the particles of chalk powder and water. Got it? So there are various others. For example, if you take up a solution of sand and water, so the solution of sand and water over there, the particles of sand, they are not uniformly distributed. Okay. Another definition for homogeneous and heterogeneous, you can also include that homogeneous are the ones where the particles are uniformly distributed. So here the solute particles, you can say solute particles have uniform distribution. This is another way you can look at it. Particles have uniform distribution. And here you have the solute particles, they have non-uniform distribution. So in heterogeneous mixtures, they have non-uniform distribution. That means at some places in the solution, you will have high concentration of the solute. At some places, you will have less concentration. So this is a non-uniform distribution. Okay. So another name for homogeneous and heterogeneous, you can say the particles are uniformly distributed in homogeneous mixtures and particles are non-uniformly distributed in heterogeneous mixtures. Okay. So understood about homogeneous and heterogeneous mixtures. Let's see some answers to these questions. Here we have what is meant by a substance. So can anyone try to answer what is meant by a substance? When we say a substance, so what do we mean by a substance? Yes, try to recall what do we mean by a substance? What do we call a substance?
Sir, it's like a type of matter which is made of a specific composition.
Yeah, a type of matter or a matter which is made up of which has a specific composition that we call as a substance. Very good, Yukta. Rohit, can you try out anything?
So they have their properties are uniform.
Okay, properties are uniform. No. What do you call a substance? What is a substance? Okay.
So the substance is they have similar particles, right?
Yeah.
Present in them.
Okay. Okay. Sampath, can you answer the second question? List the points of difference between homogeneous and heterogeneous mixtures. So, Sampath, can you give the differences between homogeneous and heterogeneous mixtures?
Yes, sir. In homogeneous mixtures, the particles or the solute particles are uniformly distributed, and heterogeneous mixture, the particles are non-uniformly distributed. In homogeneous mixtures,
Very good.
the particles can't be identified easily, whereas heterogeneous, they can be
Mhm.
identified with eyes. And in a
Okay,
homogeneous,
very good. Okay, very good, very good. So here the next word is a solution. So next we define what is a solution. Okay. So we'll see what is a solution. See, a solution, it is a homogeneous mixture of two or more substances. If two or more substances they are mixed, they form a homogeneous mixture. So we call that to be a solution. And when we say a solution, we generally mean that so what are solutions? The substances which have a homogeneous mixture of two or more substances we call as a solution. So here next word we defined as a solution. And remember what do you mean by a substance? So what do you mean by a substance? So solution, it is a homogeneous mixture of two or more substances. So first of all, it has to be a homogeneous mixture. Then only we can call it to be a solution. Also remember that yesterday we had discussed, we can have a solid solution also. We can have a solid solution. It's not necessary that a solution will always be in the liquid form. We can have a solid solution. We can have a liquid solution also, or we can also have a gaseous solution. Okay. For example, air is a gaseous solution. Okay. Yesterday we discussed of some of the solid solutions also, solid in solid. Okay. Another, a very good example of the solid solution is alloys. So alloys, they are homogeneous mixtures of metals and non-metals. So they are homogeneous mixtures They are homogeneous mixtures of metals, metals or non-metals. So if you have two metals or a metal and a non-metal, they mixed up together, they form an alloy. So we study about different alloys. So whatever alloys we see, they do not, the constituent particles, they do not lose their properties. However, we are adding some extra properties also. For example, we take the example of steel, nichrome, and brass, bronze. So all these are the mixtures of metals or non-metals. For example, steel, it is a mixture of iron and carbon. Steel is a mixture of iron and carbon. So iron and carbon, they are generally taken in the ratio of 60:40. This is a general ratio. However, the ratio can change. Okay, we can alter the ratio. There is no fixed ratio. Okay, the actual ratio of the steel, it depends on the different companies. The different companies, they can use their different constituents. It can be used in different compositions. So that is why steel is not a compound. It is a mixture. Since it can be taken up in any ratio, the ratio is not fixed. Okay. Also, the constituent particles, they do not lose their properties. Okay. So we call these substances, they are alloys and they are mixtures. Similarly, nichrome, it is an alloy of nickel, chromium, and manganese. So that is nichrome. Brass is also an alloy. All these are alloys and they are all homogeneous mixtures of metals and non-metals. Got it? So is it clear that a solution we can either have a solid solution, we can either have a liquid solution, or we can also have a gaseous solution. Got it? Yes. So a solution can be present with us in any form, either solid, liquid, or gas.
Sir,
So see, yes.
sir, can you say the constituents of brass?
Okay. See, brass consists of zinc and copper.
Okay, sir.
I'm writing here so that it will be available for you. Brass, it consists of zinc and copper, generally taken in the ratio 70:30. That's the general ratio. The ratio is not fixed. Okay, now every solution has two parts, a solute and a solvent. Right? So a solution has two parts, a solute and a solvent. Now we have to define that what are solutes and what are solvents. So when we talk of a solution consists of solute and solvent. It consists of solute and solvent. So generally, if you have a solid in liquid, such type of solutions we have. So in such cases, we consider the solid object to be the solute and we consider the liquid object to be the solvent. In most of the cases, we are taking water as the solvent because water is commonly available to everyone and it is a universal solvent. Apart from water, we can take other solvents also. For example, we can take glycerin as the solvent, we can take alcohol as the solvent, we can take um, acetic acid as the solvent. So there are different solvents which are available, but in most of the cases, we will be taking solvent as water. As water is a universal solvent, it dissolves most of the substances. So If it is a solid in liquid, so the solid substance will be called as the solute and the liquid substance will be called as the solvent. Okay. What about if it is solid in solid?
Sir,
Yes.
the
If it
solid
solid in solid, which
sir, the
yes,
solid which is in more in quantity that will be considered as solvent and less quantity will be solute.
yes, the substance which is available in greater quantity, the substance which is available in greater quantity that will be the solvent, and the substance which is available in a lesser quantity, so that will be the solute. Okay. So this was about solute and solvent in solid and solid. If you have liquid in gas, so which one will be taken as solute?
Sir, solute will be gas.
Yeah, solid in gas or liquid in gas. So in that case, whatever substance is present in a higher quantity, whatever substance is present in a greater quantity, that will be considered as solute and and will be considered as the solvent, and the one which will be there in the in smaller quantities, that will be considered as solute. Got it? Okay. So now here are certain examples. A solution of sugar in water. So if you have a sugar in water is a solid in liquid solution. So the solid part, that is sugar, it will be the solute, and the liquid part water, that will be the solvent. Right. So here we have solute and solvent. Solute is sugar and solvent is water. A solution of iodine in alcohol. A solution of iodine in alcohol is also known as tincture of iodine. Can anyone tell me any uses of this tincture of iodine? Any uses of iodine tincture?
Sir, they will apply on wounds.
It is used in,
Sir, it will be
see,
applied.
iodine tincture. Iodine has antiseptic properties. Okay. So iodine tincture is used in the treatment of wounds. If you have any wounds, so over the treatment you use iodine tincture. So generally you observe in the medical stores this as a red lal dawa. They are seen as the red medicine. Wherever you have wounds, they put a red colored solution and put it over there on the wound. So iodine solution, it is the red tincture. Now in this iodine solution, can you tell me which one will be the solute and which one will be the solvent?
Sir, solute is iodine and solvent is alcohol.
Yeah, iodine is available as solid at room temperature. At room temperature, iodine is solid. So iodine is solid and alcohol is liquid. So this is also a solid in liquid. Then third one we discussed, aerated drinks. Aerated drinks means we have your cold drinks which we drink. So what about the cold drinks? What is their solution?
Sir,
Can you tell
gas
me
and
the constituent of the solution?
sir, gas and liquid.
Gas and liquid, that is water. Okay. So which gas is used?
Sir, carbon dioxide.
Yeah, we use over there carbon dioxide and hence we call it to be a carbonated water. Then air is a mixture of different gases. A number of gases, they are uniformly mixed in air. So air is also a solution of gas in gas. So first of all, let us see what are the different properties of a solution. So when we say again, let's remind you that about a solution, when we defined a solution, the solution is a homogeneous mixture of two or more substances. So we are actually here classifying the mixtures under different categories. So mixtures, they have been classified either as solution homogeneous or heterogeneous, and which we also call as true solutions. We also call them as true solutions. we have suspensions and colloids. Okay, so suspensions and colloids. Now, what are solutions, suspensions, and colloids? So, solutions we have discussed, they are also called as true solutions. And here, the size of the particles is very small. The size of the particles is almost of the size of the particle of water, that is approximately the size of 10 to the power minus 9 meter, which is a nanometer. So the size of the particle is very small in the case of solutions. In the case of solution, the size of solute and the solvent is very small. In the case of suspensions, the particles are of the size of few millimeters. Here, in the case of suspensions, the particles are of the size of few few millimeters. So generally 10 to the power minus 3 meter, that is the size of the suspensions. In the suspensions, the size of the solute particles is approximately 10 to the power minus 3. In the case of colloids, the size of the particles is in between them. So roughly between 10 to the power minus 4 to, you can say, 10 to the power minus 6 or minus 7. That is the size of the particles in colloids. So the size of the particles, they are not very big and they are not very small. So generally, colloidal solutions will be formed if the molecules are very big. So those substances which have very big molecules. So here, the solute particles have big molecules. Solute particles have big molecule or large molecules. For example, we can consider for the colloids a mixture of oil in water, that is a colloid, milk in water, starch in water. Okay. So mixture, a colloidal solution of starch in water can be prepared easily. So all the colloidal solution, the particle size will be bigger, between 10 to the power minus 4 to 10 to the power minus 6. So they will not be visible with the naked eyes. You cannot observe the colloidal solution particles with the naked eye, but they are quite big. They can also pass through the pores of the filter paper. Okay. But for the suspensions, the size of the particles is quite big. They cannot pass through the pores of the filter paper. Okay. And for solutions, yes, they can pass through. So in the next class, we will be discussing again about solutions, suspensions, and colloids. Today we have completed our discussion about the solutions. What are different solutions? Like we had seen uh, a solution of solid in solid, solid in liquid, and others. Okay. So today we have discussed about the solutions. In the next class, we'll discuss about the suspensions and colloids. Anyone having any doubt regarding this?
No, sir.
No, sir.
No?
No, sir.
Okay.
No,
Okay,
sir.
so bye all of you.